classifying matter. Matter. Matter is anything that has mass or substance and has volume, takes up space. Everything is matter. Everything is matter. Remember, matter has mass and has volume, takes up space. Elements. Elements are pure substances that cannot be separated into simpler substances. Elements cannot be separated. For example, sodium and chlorine are elements. Compound. A compound is two or more elements together. For example, sodium is an element and chlorine is an element. Two elements together equals salt, sodium chloride, NaCl, sodium chloride. Salt is a compound because it is made of two or more elements. Mixture. A mixture is two or more compounds. A compound, for example, salt, plus a compound, for example, water, equals a mixture. For example, salt water is a mixture because it is made from two or more compounds. Combine means to come together. Separate means to break apart. When we have two and we combine into one, or we have one and we separate into two. When compounds and mixtures combine or separate, they do so differently. Compounds combine or separate chemically. For a compound to separate, there must be a chemical reaction. Mixtures combine or separate physically. There is a physical separation or combination when you're looking at a mixture. So compounds are chemical, mixtures are physical. There are three types of mixtures: solutions, colloid, and suspension. Solution has the smallest particles. You can see these particles are very, very small. Colloid has mid-size or medium-sized particles. And suspension has the largest or biggest particles. Solutions are homogeneous. Homo means the same. All of these particles are the same distance from each other, the same concentration. So solutions are homogeneous. Colloids and suspensions are heterogeneous. Hetero means different. There is different numbers of molecules in heterogeneous mixtures. Colloids and suspensions are heterogeneous. Homogeneous mixtures, for example, solutions, are evenly distributed, and you cannot cannot see individual particles. When I look at my sugar solution, I cannot see the sugar. I only see the solution. In the Kool-Aid, I cannot see the individual Kool-Aid particles, only the Kool-Aid. So homogeneous solutions are evenly distributed, and you cannot see individual particles. Heterogeneous mixtures are unevenly distributed. Unevenly distributed. For example, there's some here, some here. It's not the same. They're unevenly distributed. And you can see individual particles. I can see the white particles in the snow globe. I can see the noodles and the chicken and the carrots and the vegetables in the chicken noodle soup. I can see the meat and vegetables on the pizza. The Tyndall effect. The Tyndall effect is when the particles in a colloid or a suspension scatter light. This is an example of scatter light. The light is scattered, it is spread out. It scatters the light beam as it passes through the colloid or suspension. Colloids and suspensions scatter light, and this is called the Tyndall effect. Here's the Tyndall effect again. The light in a colloid is scattered. The light in a solution is not scattered. So in this picture, here is our solution, not scattered, and here is our colloid, scattered. Here again, solution, not scattered, colloid, scattered. So a solution will not scatter light. A colloid will scatter light, and a suspension will scatter light. Colloids and suspension scatter light. This is called Tyndall effect. Tyndall effect. Also, suspensions will settle out over time. Colloids and solutions will not. If I have a suspension and I wait some time, the suspension will settle out. The particles will go to the bottom of the glass, and then the top will be different. The colloid and the solution will be the same. Here's a better picture. Here's a suspension. We wait some time, and then it settles out. The black goes to the bottom. Suspensions will settle out. Here's some oil and water. That's a suspension. Here's another suspension. You can see at the bottom it's a different color. That's because suspensions settle out. Here are some examples of solutions. Gasoline is a solution. Water and salt, or water and sugar, is a solution. Soft drinks, sodas, for example, Coca-Cola, is a solution. Window cleaner is a solution. There are many different solutions. Here are some examples of colloids. Milk is a colloid. Smoke is a colloid. Fog is a colloid. Clouds are colloids. Milk, smoke, fog, cloud. All of these are colloids. And suspension examples. Oil and water is a suspension. Dust, this cloud of dust right here that you blow off of a book, is a suspension. Italian dressing that goes on your salad Italian dressing is a suspension. Just as a reminder, these are the three kinds of mixtures: solutions, colloids, suspension. Solutions have the smallest particles, they do not scatter light, and they do not settle out. They are homogeneous mixtures. For example, lemonade, Coca-Cola, sugar water, salt water. Colloids have mid-size particles. They do scatter light, but they do not settle out. They are heterogeneous mixtures. And colloids are, for example, milk, smoke, clouds, and fog. Suspension. Suspension has the largest particles. It does scatter light, and it does settle out. It is a heterogeneous mixture. For example, oil and water, dust, and Italian dressing. All of these are the three types of mixtures.